No one's ever operated in the orbit before. That was one of the reasons why we refer to Capstone as a pathfinder. So we were kind of going out there to validate that, and certainly, we can model these things, but actually going and flying it, we learned a lot of lessons about how to actually plan maneuvers and how to schedule things. Some of this stuff just becomes like a scheduling problem of when can you talk to the satellite, when can you send it commands, when can you perform maneuvers. All that stuff becomes kind of a thing you have to work, and you don't get to necessarily control it all yourself, right? So that there's a lot of interesting operational lessons that we learned through that process.
Hey everyone, and thanks for listening to another episode of DIB Innovators. Today I'm speaking with Brad Cheetham, Chief Executive Officer and President at Advanced Space. Brad, thanks for chatting with me today.
Thanks for having me on, Dave. I'm looking forward to our conversation today.
Yeah, this will be fun. Fellow Colorado company doing some amazing things in the space realm. So to start off, why don't you tell us a little bit? I mean, you've got a fascinating background of just how you found yourself founding a space company that you now are on the other side of the moon with a satellite. Pretty cool.
Yeah, absolutely, Dave. Yeah. So for us, that journey started actually about 14 years ago in Boulder, Colorado, where I know you're sitting. And for us, what it really came down to as we started the company was we had a purpose, my co-founders and I, that we really wanted to find a way to enable the sustainable exploration, development, and settlement of space. That was our driver, our motivation for our careers. And when we were looking around, we just 14 years ago didn't see that anywhere. We didn't see a company that we could go accomplish that mission as we saw it. So as any good, naive young entrepreneur would, we said, why don't we try to start a space company? But as grad students or I should say, we weren't billionaires. So we had to basically find a way to start a company that didn't involve a lot of money. And so what we did was really get into how to create technologies and capabilities and software and mission design solutions that would allow us to go provide value to the industry without giant rocket factories or satellite production facilities. So for us, that was kind of the vision, and we've been fortunate over 14 years to grow on that and to really be able to build it into something like you said, where we have a satellite that for over 2 years now actually has been flying at the moon. That's our CAPSTONE mission, the Cislunar autonomous positioning system technology operations and navigation experiment. And that's been going on for 2 years now. Very exciting stuff as a small business to have our own satellite that we own and operate flying around the moon for NASA and being able to cascade those capabilities for other customers.
Yeah, it's so amazing. And so you were at CU. What was your time before that? So, you were just was that the natural progression? You got
Yeah. So the journey, journey was for me. I did my undergrad at University of Buffalo in New York. And then I went and spent a little time at NASA's Goddard Space Flight Center in Maryland. Went to CU Boulder to do my PhD, and sort of through that journey of doing my PhD, was doing research on the sort of fundamental navigation capabilities that we ended up using for CAPSTONE. So that was kind of it makes sense in hindsight. It probably didn't make sense at the moment. So we're doing that fundamental research, and then also started a class at CU Boulder to really kind of track how the industry was changing. The aerospace industry was evolving. And so kind of as those things came together, I often joke, instead of writing the dissertation after, 5 or 6 years of doing research, I decided it'd be more interesting to start a company. So we went out and that took off and really has become kind of the rest is history, as they would say. But yeah, the PhD experience at CU brought me to Colorado, but also gave us that sort of industry and technical context to start what we've really been doing at Advanced Space now for over a decade.
So that's cool. So 14 years ago, that class that was sharing what it's like to have a business in space, what was it like then? Because I know obviously it's changed rapidly in the last
a lot has changed.
Years.
Yeah, it was very interesting. I remember really vividly back then. I mean, there's a few things. One is we, as a company, as people starting a company, if you watch movies and you don't really know what you're doing, the first thing always happens in a movie is you try to raise money, right? So going back to that time frame, we thought that was the first thing we had to go do, and so we went through that process. And I could say that's something that has changed a lot. Back then, there was no real organized interest in people investing in space companies. And for the most part, there was really no interest in it. So it was really a tough area just to find some people who understood what space was or what aerospace was. And we ended up not taking outside capital, which was a long story there. But the other thing that was interesting and has changed quite a lot is in that time period, new and small was not good, right? So in the industry at the time, it was all about heritage. It was all about things that had been working for a long time. There wasn't an interest necessarily in saying, hey, let's try something new or let's, disrupt the sort of status quo. That wasn't yet in vogue. So we really started out really with a steep hill to climb. We had ideas on ways we thought things could be done better, but we were really working against headwinds. I think in that period of the industry, there was a lot of headwinds to face. And then we were very fortunate because we were working on a lot of these things as that started to change over, the last 10 or so years where, for example, going to the moon became a priority again, working with commercial partners became a priority, new, smaller spacecraft, a lot of these innovations that had been kind of independently being mature really came together for us at a good time. So it was a tough start, but I think that made us better as we have grown because we knew a world where there was no real interest in what we had to offer. So as we've picked up momentum, it's certainly been a much more enjoyable journey than facing all those who cares and closed doors.
So a couple of things for that. Was there a tipping moment, like in the industry? Was there something that really made it go, ding, a threat from an adversary or?
Yeah, that's a great question. Being in it, I'm sure like I would have told you there's a few of them. I think it was really a fortunate convergence of, obviously SpaceX changed a lot of the paradigm for launch and for other things. The CubeSat and small spacecraft capabilities have really, gone leaps and bounds from where they were even 10 years ago. So I think it was a lot of these little things that probably any one of them you could take, and say that was the tipping point. But to me, it was this sort of a collective momentum. I like to think about it as a sort of a momentum towards kind of the best of both worlds, if you will, between what government's trying to do and what industry can provide. And I think we're continuing to see that evolve, but I think that's here to stay, which is exciting because, through that journey, you're never quite sure. Like, are we making false progress? Are we going to fall back? And I think now we're kind of over that hill in a good way, in the sense that I think this is the way forward is what we've been doing.
So your initial vision, I imagine it's just like we started our company. A lot of people do. Three guys in a shed. It was us. I don't know what. A couple of guys.
Four guys in a loft for us.
Yeah, there you go. 4 guys in a loft. At the time, did you envision sending some to space, or was it more like, let's do it, small bites? Let's start with just thinking about navigation of satellites. How did that kind of progress from the technology roadmap, and were there any big shifts in that as you were on the journey?
Yeah, that's it's an interesting journey when you think about it, because what we had from our sort of model was provide things that we could do today of value for our customers, right? It wasn't like, we'll build it and hopefully they come later. We were trying to avoid the sort of speculative approach, because one of the things in aerospace is that timing is really hard to predict. So we really were trying to avoid that, lock into, okay, 2-3 years from now you have to show returns. That was something we always wanted to avoid in terms of like an investment situation. So for us, it was, how do we build on what we can do? And so what we could do early on was, figure out how to design, orbit transfers, how to do navigation, how to build those software technologies around that. And what was interesting is that we saw, and CAPSTONE was really kind of a great example of this, where we saw was as those other technologies I alluded to, like launch and spacecraft and other operational capabilities came online, they were all kind of coming online independently. And so what we were able to do for CAPSTONE was see that one of the like critical enabling things that allowed us to send something the size of a microwave oven to the moon on a rapid schedule for sub $30 million was the actual orbit approach. So the thing that we happen to know a little bit about was the enabler to get a small spacecraft there. So the sort of standard approach we would have had a much bigger satellite, would have cost much more, factor of 3 or 4 at least in terms of cost and size, and that would have put it outside of the realm of, I think, think what NASA would have found interesting. So for us, it was really those orbit designs, those novel operations that we were working on enabled the mission. And once we kind of realized that, and then we started to look around and see that, we had these options for launch and spacecraft and operations, we were then able to say, okay, well, with that enabling technology, in this case being the orbit transfer of all things, but with that enabling technology, we were able then to put together for NASA, in the case of CAPSTONE, an end-to-end mission that we were able to go execute and continue to execute.
And so I was an aeronautical engineer, not an astro. So what you're saying is really, it wasn't necessarily a technology other than the technology to harness and really understand it, but you're using the gravity pulls and the orbits to figure out how super efficiently to put something at the moon.
Yeah, and in terms of serendipity, it was actually a similar approach that I had used when I was working at NASA's Goddard Space Flight Center on a mission supporting the work they were doing, where they were taking some of these same advanced astrodynamics to move satellites around. That kind of gave us a start of, hey, this is possible. And then my co-founder and our CTO, Dr. Jeff Parker, kind of wrote the book on how to do these transfers when he was at the Jet Propulsion Laboratory. And so we kind of pulled those together. And again, with the research I was doing and how to navigate these orbits, how to operate these orbits at the moon, we were able to kind of put that together and say, hey, look, there's an option here. It's kind of, maybe it's a little crazy. And I'll be honest, as we were pitching this idea for a small spacecraft rapid mission to the moon, before COVID, we were looking at an 18-month start to launch. COVID made that about 33 months, which we're still pretty proud of. But as we looked at that, we said, we proposed it, and people came and said, that's not how this works. That's not possible. I mean, we had a lot of, people telling us why we were idiots and why it was a waste of time and money to even try. And so as we got into it and we were able to deliver, not only was it exciting to demonstrate the technology and mature some of these capabilities, but if I'm being honest, it was also really great to kind of stick it to a bunch of people who said we shouldn't even try and it wasn't possible.
Yeah, I love that. Yep. Not possible. Yes, it is. So we'll come back to that a little bit. But so from a business perspective, you have, you're running this. Have you taken capital? Like, what has that, journey been as you've gotten to this point?
Yeah, no, so we haven't, as a business, taken outside capital. So all of our growth has been funded by our customers and by our commitment to the company's growth and to our purpose. So really focus on that reinvestment and not just, reinvestment in a lot of ways, but really a reinvestment in technology. And so as we have been looking at these capabilities, we kind of try to look, what are we going to need in a couple of years, and we try to work on that ahead of the need as much as we can. And so, we're proud that some of our team has been working on artificial intelligence, machine learning, neural network stuff for years now. Obviously, it's very in vogue to talk about AI and machine learning and all these things with the large language models. But we've actually been like reformulating how satellite operations are conducted, using the best of AI, machine learning, and these related tools, even to the extent that we have taken some of those tools and actually have flown them on our satellite at the moon and demonstrated them, which is something we're really, really excited about.
What an achievement. Hardware company put a satellite to the moon without taking outside capital. Bravo, sir.
Yeah. Yeah, no, it's been a journey, like I said, and I wouldn't say, it's not something that anyone can do alone, right? So for us, it's been a team sport. Certainly, without NASA's support, we couldn't have done that. Without our mission partners on CAPSTONE, one of the things that's interesting about advanced space is we don't actually build hardware. So we had mission partners provide satellites and components and subsystems, and so as we were developing that, we're able to really go out and find, what we believe to be the best fit for whatever mission it is that we're working on, and then put those together to deliver. And I think that's part of the opportunity as we think about it from an industrial-based perspective for the government, is that there's not this vendor lock anymore. There doesn't need to be this vendor lock anymore to some of these systems, where we can go out and find sort of the best combination of elements and put them together at a really competitive cost. And I think sometimes people miss this too. It's not just cost in what we do, but it's also schedule. We are operating, under schedule pressure now that is, serious. Like for us on CAPSTONE, we were a pathfinder for the Artemis program for NASA's goal to put humans back on the surface of the moon. You can't be late if you're the pathfinder, right, Dave? It's like your pathfinding is no good if you're second. Like, so there are some, no kidding schedule pressures that come into these things, and they become like level 1 mission requirements that you have to be timely. And we've seen time and time again on other programs, and that that's not how they've been operated. And so I think that's part of this new paradigm. It's not just cost, but it's also really got to be schedule.
Absolutely. If we take then, let's just talk through CAPSTONE. So talking about what is that mission and what was the initial focus that you were supposed to do, and how did that turn out?
Yeah, so CAPSTONE, originally set out as a rapid program, like I said, to send a small spacecraft to the moon. The objectives were really around demonstrating operations in a new orbit that hadn't been used before, but is planned to be where NASA's lunar space station called Gateway will be put. So it was really figure out some of those operations, validate some of the requirements for systems NASA's building. So you can imagine like a $30 million system involving, programs that are hundreds of millions of dollars. It's kind of an intimidating proposition, but it was really about pathfinding for NASA, and then also demonstrating some navigation technology, some onboard technologies. We call this Cislunar Autonomous Positioning System, or CAPS, in the first half of the acronym, obviously. And so for us, CAPS represents something that we think will enable a lot of future operations at the moon. And what I mean by that is that today, when we operate CAPSTONE or other people operate missions, all of the work to figure out where the satellite is at the moon, at least, is all done using these really exquisite and in high demand ground stations or ground antennas. And so right now, that ground network is at capacity. Right. So we're fortunate to have it as a mission. We depend on it. But as we think, well, what if there's going to be, 5 or 6 more missions like ours out there? There just isn't enough bandwidth or time on these dishes to operate. So the key piece of CAPS as a navigation technology is to try to enable satellites to figure out where they are more efficiently. So either talking to each other or listening to ground stations or what have you. So for CAPSTONE, we closed a cross-link, or we talked to a satellite NASA had put at the moon about a decade earlier, called the Lunar Reconnaissance Orbiter. So this is really kind of a crazy part of the experiment, because the Lunar Reconnaissance Orbiter, we couldn't change it. It's been at the moon for over 10 years. So we had to basically come to the moon with a technology to talk to that satellite, which it was never really designed to talk to another satellite. And then from that demonstration of this communications, figure out where both satellites are just from that crosslink, just from talking to it. And so that technology in and of itself, then you can imagine reduces the amount of time any satellite needs to talk to the ground to figure out where it is. And you can also think about using that for, relaying data and other key things. So that sort of technology maturation has been a huge success. The mission has been fully successful. We've hit all of our operational milestones. It was designed to operate at the moon for 6 months. We crushed that 6 months. It was great. We did an extra 12 months, which was sort of in our original plan. We thought maybe we could get to 18 months. We're now I've been operating for over 2 years, and very excited that just actually this morning with NASA, we confirmed a continued experimentation plan through the end of this calendar year at least, to keep pushing the state of the art for autonomy, for navigation, for these great technologies that we think will enable future missions. So as a small microwave oven sized satellite flying around the moon, it is doing quite a lot of work. We often call it the small but mighty mission, but we're continuing to use that platform to demonstrate not just autonomy and future operational experience stuff, but like I mentioned earlier, artificial intelligence and other really innovative things that I think that we see will hopefully enable future missions.
So the navigation piece of it, by the way, congratulations. That's
thank you. Yeah.
Awesome news. From a navigation piece, so it's almost like GPS. You're trying to figure out a system, a methodology that when you're far away around the moon or other places, there's a way then to the satellite to know where it is.
Yep. And to get data back to the Earth even too, right? So it's a communications and a navigation challenge. And for us, there's different ways of thinking about it. I'll say for us, the idea I mentioned earlier, timing in this industry is hard to predict, right? So one of the challenges, if you think about, well, why don't we just build a, GPS for the moon? Right. Well, the problem is these satellites usually have 2 or 3 year lifetimes, right? So if you deploy a whole bunch of satellites at the moon to do, GPS at the moon, and you're 2 or 3 years early, you may have nobody to use your satellites that you put up there, right? So our idea is more of a peer-to-peer system where the satellites that are going there can talk to each other, and you can maybe have, one or two of them that has a little extra capability. You don't need to necessarily build out this really expensive, time-dependent infrastructure. You can kind of create more of a peer-to-peer system, and so that's really been the focus that we've had in developing that technology from the beginning. Obviously, I hope in the near future, I hope we do have these dedicated, awesome, constellations and satellites at the moon to do this mission for many, many, many users. But as we start that up, for us, the big thing is having it be something that is more peer to peer and more maybe practical in terms of timing, because timing is hard to predict.
And then so on the orbit side around the moon, 2 years. Why were you thinking it might not last past a year, but it just orbital decay and have it?
Yeah, so for missions out there, there's a few things that can go wrong. One is you can run out of fuel. So our satellite has to do maneuvers to stay in its orbit. And as a mission that was designed by a bunch of orbit nerds, the one thing we were never going to run out of is fuel. I'll be honest with you. That was we were really precise with how we planned that, how we operated it. So we have plenty of fuel. The other things though that we think about are the radiation environments out at the moon are can be much more severe than they are in low Earth orbit. The power requirements, the thermal impacts, when we have these things, it's just much more extreme. And so what we have seen in other missions, not just our own, but is that there are failures of those components over time. And so as we set it out, we said, look, we can't make it totally bulletproof to all these possible failure modes, for forever. So we kind of put that mission life timeline on there. But we've been really proud of the system itself. It's really, outperformed our expectations. And we actually are, we don't have a limitation on fuel. We don't know what it may be ever that ends the mission, kind of hard to predict. But for us right now, we see it as, it is every day we have it up there. It's an opportunity, and we're taking full advantage of it.
And is the orbit around the moon similar to orbiting around the Earth as far as you can be kind of stationary over a point in the moon, or you that can?
They're a little different. So this specific orbit is called a near rectilinear halo orbit, or NRHO. Obviously, like kind of not a marketing guy came up with that term. But the idea is this is a really special type of orbit. It's relatively easy to get into that orbit and out of that orbit if you're coming back and forth to the Earth. It's also an orbit. From that orbit, you can get pretty much anywhere on the surface of the moon you want to get to. And when we think back to Apollo, we were when the systems were going down, they could only go to a pretty narrow stretch of the moon based on how the orbits worked when they arrived. So this would give NASA access to pretty much anywhere on the moon, and it also creates this really, really opportunistic and efficient place to change vehicles or to store stuff where it's relatively easy to get back and forth from the Earth, and you can get to anywhere on the moon. So the idea here is this is sort of like our waypoint to repeatable access of the moon from like an orbit perspective. It has a lot of benefits. It's never behind the moon, so it's kind of interesting. We can always see the Earth from this orbit, and it has limited solar eclipses, so limited times where it's in the shadow of the Earth, which in Earth orbit, low Earth orbit, maybe that's, tens of minutes, not hard to design for. It's not easy, but out at these distances, those eclipses can be hours long. And so this part starts to become some of those sort of hidden gotchas if you think about operating at the moon, where it's like, it's pretty hard to design a satellite that can go, 8 hours without sun on its solar panels and without freezing. And so that's sort of a special piece of this orbit that we've been demonstrating for CAPSTONE that again, NASA will be using for Gateway.
Are you the first one to actually do this orbit?
Yeah, so no one's ever operated in the orbit before. That was one of the reasons why we refer to CAPSTONE as a pathfinder. So we were kind of going out there to validate that. And certainly, we can model these things, but actually going and flying it, we learned a lot of lessons about how to actually plan maneuvers and how to schedule things. Some of this stuff just becomes like a scheduling problem of when can you talk to the satellite, when can you send it commands, when can you perform maneuvers. All that stuff becomes kind of a thing you have to work, and you don't get to necessarily control it all yourself, right? So that there's a lot of interesting operational lessons that we learned through that process.
Probably a stupid question, but I'm going to ask it. Does this same kind of orbit concept align with Musk, let's go to Mars? Like, does that same type of orbital dynamics exist on other planets or other moons?
Yeah, so these general, orbits, the orbit exists. The uniqueness of it is that it exists because it's being pulled on by both the moon and the Earth. So it's not really just in orbit of the moon.
Right.
It's sort of like, the way I talk about it is it's about a week to go around the whole orbit, and for about a day, it's relatively a lunar orbit, and for about 6 days, it's really more of an Earth orbit, just really far away from the Earth. And so those same type of orbits exist at Mars and have been evaluated similarly for the benefits they have. But one of the interesting things for the NRHO specifically is that we've also looked, for a variety of reasons, at transfers that could actually go from this orbit at the moon and go to Mars. So, go back, fly by the Earth and go off to Mars. And so in many ways, the gateway was envisioned as a gateway to the moon. But it's also, I think, in its same exact configuration, could be helpful in exploring Mars and other planets like Venus and elsewhere, where we can send payloads up, maybe hold them until the timing's right, and then deploy them to go to the different places we need to explore. So yeah, it definitely fits into that mindset. I mean, obviously, one of the key things for NASA on the Artemis program is that it is a moon to Mars program, right? So what they're looking at are what are the things they can do at the moon that help us get to Mars. And as we look at things like navigation technologies, that is a key thought of like, how do we operate? Operating at the moon is difficult. Operating at Mars is way more difficult. And so, we got to really work to burn down some of those technical risks in our backyard before we, go on a journey, several months away to Mars.
So you're still not building hardware. You're still just
Right.
partnering concept.
Yep.
Do you have any new launches that you're going to go out and or is everything still just on the CAPSTONE mission?
Yeah, so we have a few different programs we're working on. Some of them are different levels of maturity. One of the ones that we're excited about, which will be coming up hopefully later this year, is we're supporting a program called Escapade, which is actually led by the University of California at Berkeley for NASA. But the Escapade mission will be the first to fly a formation of 2 satellites around Mars. So it's a really exciting program where we've been supporting it for a few years now. And that mission, our job is really try to help make sure we get the satellites there. So again, sort of path planning, trajectory planning, but then also because it's 2 satellites, they have to fly a very specific formation when they get to Mars. And so our job is to help plan that formation out. So that'll be an upcoming launch. We're really, really excited about that. Really new technologies, in that case, new science that's going to be collected because of this, something that's really awesome. And then we also have a few other programs, like I said, looking at lunar missions and looking at other things that we'll be talking more about in the next few months.
That's very cool. So partner-wise, talking about partners that you have found, both commercial and government, what are your key partners and what are some new partners that you're excited about what they're doing?
Yeah, well, I'd say, in terms of partners, the biggest partner for us has been NASA, especially on CAPSTONE, but some of these other technologies. And I think that, that can often be said sort of like off the cuff, like, they're the ones sending the checks. So of course they're your partners, but really for CAPSTONE to be successful, it was a true partnership with NASA. And so to kind of give just a little bit of context, and this has all been on the public, but CAPSTONE was not a mission without its challenges, I'll say. So after we launched, which happened to be the 4th of July, and celebrated the launch and separation of the satellite stopped talking back, which I know, I've got little kids. Sometimes I enjoy when they stop talking back, but when your satellite stops talking back, it's not great. So we had a major anomaly to overcome in the first just few days of the mission. And then about halfway to the moon, we had a valve of our propulsion system stick open during a maneuver, and the satellite spun up uncontrollably. And we were very close to losing the mission at that point. And it was because we had the team at NASA's Deep Space Network and throughout NASA, in both of those cases, really showed up and brought their A game. It is not an exaggeration to say that both of those things could have ended the mission entirely. So we were able to overcome, 2 near-death experiences on the way there because of those NASA partners that we had really across the agency, and then also, from our industry partners that we had that were able to not just build and deliver great systems, but then also, support them as we were operating. This system, because of the anomaly with the thruster, we basically were pointed in the wrong direction. We almost ran out of power. And so one of the things that, I found out after the fact is it turns out you can freeze propellant on a spacecraft and thaw it out and still fly a mission. That was certainly not designed to do that, but we didn't have a choice for Capstone. The way it worked out, we froze the propellant tank. And so we had, our propulsion vendors were like, well, we've never tried this. It's not supposed to work, but here's what we think could help it to be successful. And it turns out we were able to recover it, pretty much fully recover it. So it was that kind of thing where it's really truly that partnership where people are offering help and accepting help, right? And I think that might sound simple, but I think in our industry, I think it can be very competitive. People can get really wrapped around their ego or whatever, their self-importance. And so I think really being willing to have that partnership where you can ask for help and people can offer help and you can find a way to work together. I think that is the best of what our industry brings on these type of missions. And you hope you don't have to deal with it, but it's better to have those good relationships and not need it, obviously, than to not have them and wish you did.
Yeah, absolutely. Do you think that's somewhat because your technology is both kind of pathfinding new and super enabling to everything else? It's not really like in the competitive space. I mean, I could pick some other companies that I've interviewed.
Yeah.
There's definitely competition there. This is like really groundbreaking. So we think that helps?
I think it could a little bit. I mean, I think there's still competition in a lot of these component capabilities, and so there is still like the propulsion system we use on Capstone is used on other missions in Earth orbit and other places. Obviously, that vendor has competitors in that space, and so it's sort of, I think, a mindset of really, for us, we are 100% focused on the mission. Whether it's our mission as the prime in the case of Capstone or when we're supporting other people's missions. For us, at least at Advanced Space, our culture we are focused on the mission. And so whether that's good or bad for us, it doesn't really matter. Like, we need to go accomplish a mission here. That's what we're hired to do.
Does, as you see this, because some other folks I've had on, just having space situation awareness is super challenging. I mean, there's a lot up there and it's increasing at a drastic rate. Will this reduce that? I mean, you kind of mentioned it. I'm just trying to tie that, connect them. It will reduce the requirement to actually have to track everything, because now your satellites, in theory, if they have your technology on it, will just be able to say where it is, and then
absolutely. So CAPS as a technology will help us figure out where the satellites are that are functioning and that are cooperating, right? There's a couple of key caveats. And so with that, we envision that you have sort of this peer-to-peer network, again, peers, so friends, that would be able to not just figure out where they are, but also potentially provide some of that, space traffic coordination functionality, ideally in more of an automated way. Again, trying to enable scale of operations without bottlenecks here on Earth. But these orbits also that we're talking about, and for Capstone and similar orbits, are also potentially really valuable for space situational awareness, not just around the moon, but about how things are coming from the moon to the Earth, or going to the Earth to the moon, or even back in more traditional orbits at the Earth. And so for us, we kind of think of Cislunar as kind of this high ground from which we can observe what's going on, keep track of things, but also provide sort of we call it an over-the-top resilience to some of these lower orbit systems. And so, a lot of times we talk about, Cislunar or Earth orbit, kind of like they're different. But for us, we think like we're going to need that awareness that you referred to. We're also going to need, communications. We're going to need navigation. We're going to need all these capabilities, these requirements are going to exist through a continuum, right, from low Earth orbit all the way out past the moon. And so as we're thinking about these technologies, it's really not just about, hey, what's this applied to the moon, but really how does that apply to other orbits that we have to operate in from a commercial perspective or from a government perspective.
Super exciting, very powerful too. So if we look at like lunar exploration, which again, this is a big part of that, what are some key technology hurdles that you see that still exist that we need to overcome as a country?
Yeah, I think that's a great question. There's a lot of pieces there. I think one of the things that we have identified and we're trying to get at, and I've alluded to it, is really trying to get at operations. Obviously, they need to be reliable, they need to work, but we got to find a way to get them to scale. Right, like we've seen in Earth orbit, we went from dozens of satellites in a constellation now to thousands. incredible, transformations there. So if you think about what do we need to do at the moon, these one or two kind of key successes at a time are obviously really impressive and important. But I think for us, it's about how do we operate at scale? How do we do communications and navigation at scale? And I think a lot of those kind of foundational pieces exist in similar ways to like they did for Capstone a couple of years ago, right? Where we have launch, we have spacecraft, we even have landers that we've seen recently. Great success from the team at Firefly to land on the moon as a commercial company. So you see, we sort of have each of these pieces, but I think what's really missing, or what we're trying to work on, is how to put those together in a repeatable fashion so that we can get several of these types of missions going at any one time. There's plenty of different things we need to understand about the moon, about the surface of the moon, about these environments, things we need to have for awareness. And so when we start thinking about this, from transitioning from a sort of one-off great success like a Capstone or like Firefly did with their lander, to a something that is repeatable and at scale, I think that's that challenge, is really shifting not just necessarily the mindset, but some of those underlying technologies. Like I said, we're just at capacity on a lot of our Earth-based infrastructure. We got to find ways to shift off that.
So using that then as segue to the next question, 5 years / 10 years from now, what is the lunar mission exploration? Where are we going to be?
I tend to be accused of being somewhat optimistic, right? I'm that crazy guy that thought a 12-person company could send satellite to the moon, and we did. So, but for us, I think what's really going to be exciting is as we hopefully get to that point where we get through those bottlenecks I just identified. I think what we'll see is a diversity of mission operations at the moon that really start to return a lot of value from a government and from a commercial perspective around things like identifying, the value-added awareness, like we talked about, or the value that Cislunar can play to lower orbits in terms of over-the-top resilience, but also in terms of simple things like mapping the surface of the moon in certain ways and figuring out, what resources are where. I think there is a tremendous opportunity of the moon as sort of our next step for humanity to really get out there and understand more about Earth, understand more about the universe, but then also find creative ways to add value back here on Earth from things that we might do at the moon. So I'm tremendously bullish. I think we'll have many different, a diversity of orbital missions and surface missions, and certainly in the next 10 years, I think NASA will have a really robust and exciting surface presence with humans there, which I think is really important, right? We need to get back to an era where people are at the cutting edge of our exploration, and I think the moon is going to be a really exciting place to see that happen.
Absolutely. Super exciting. Well, if you go back, looking what you've learned, what an incredible journey. And again, I'm still slightly flabbergasted that you were able to launch something that's still cooking around the moon for less than $30 million with 14 people, whatever you said. So,
yeah.
You got some of your new listeners or folks that are just sitting, folks that tune in, or just general recommendation of like someone that's at a space company or something that has an idea that wants to break in and be part of this journey. Mm-hmm. What would be like a couple of big lessons that you would say, advice as they jump onto this train?
Oh, that's a challenging question, Dave, because I think everyone's got a slightly different journey. But I think, for me, if I was looking back on it, some of the things that were important. So first of all, I really love what we do in terms of what our company is doing. And I think that's important because I think if you don't love it, right, as much time and so as that you got to put into these things, if you don't love it, you're going to burn out and you're going to be miserable, right? So first of all, find something that you really love that you can't, imagine not doing, or you're just so passionate about. That would be number one. And then number two is be really careful and thoughtful about how you want to go about following that passion. The reason I say that is because I started on this journey as an engineer doing really deep technical research, which has certainly helped me understand how to guide the company. But I don't really do much of that anymore, right? So if you really want to get into starting a company and doing this stuff, at some point you may have to decide between doing the things you love or the things that your company needs you to do. And so for me, it was okay because my passion was making sure we got these things done. And I really love what we do. But it was certainly not like a way for me to do more technical work to start a company because, you have to figure out things like, payroll and benefits and there's a lot of other stuff that goes into running a business. So, like I said, for when we started, we didn't see another place to do it. So we felt like we had to start something. But I always challenge people to make sure that you figure out what it is that you're excited about. Like if the idea of starting is more exciting, you're willing to dig through some less than fun things. I encourage everyone to try it, but I would say I was very naive going into it and realizing that, when you're in charge of a company, and we've been growing a lot lately, only the hard problems come back to the CEO, right? The easy stuff gets solved, the fun stuff gets taken care of. It's only the ones that are not fun and not easy that we get to deal with. So I was just cautioned that part was something I certainly did not appreciate when we started on this journey, but because we have a great team and we're doing great stuff, I love every day of it, but it is certainly not what I expected it to be when we started.
I think that's great advice. It's not the results and the press and all seem happy, but it's a grind.
Yeah.
To run any company, but I can only imagine in the space you're in. Well, I also give you kudos. I know you're a big fan of, culture matters.
Mm-hmm.
You're a big part of the community. I know you host happy hours. So, I also give you kudos for that, because that's hard for a CEO to find time to, prioritize culture. I mean, you want to do it, but it also you pulled so many directions, and to engage in the community and engage in other boards and activities, which you're, member of, quite a few. So, and giving back. And so I think that's awesome as well. So really appreciate that.
Yeah. Thank you. For me, it's I feel like we all, like I said earlier, we all kind of in some ways are in this together. Yeah, sometimes there's competition and stuff, but really at the end of the day, I think most people are in this industry because they share the same purpose or similar purpose. And so for me, the extent we can do that to help the industry grow, I think helps everybody, and hopefully helps us too.
Absolutely. Well, Brad, this has been a hoot. I look forward to sharing a beer with you at one of your, happy hour get-togethers here soon. But if folks want to continue to follow, like what are you doing? Just because it's super, super cool. How's the best way to do that?
First of all, I appreciate the opportunity to be on with you. It's been great to have this conversation, and maybe the next episode that we do together, we could do over a beer and a little different, topic like maybe to get to. But yeah, love the opportunity. For folks who are interested, our website is advancedspace.com. We have kind of our news postings there. We also have, quite a few job openings right now. We have grown. We started Capstone. We had less than 20 people. We are now at almost 100, and are hiring about 20 roles for right now for projects that we have a need for. So cool. I'll say, it's a little self-serving there. Sorry, Dave, but anyone who's interested to check out our website at advancedspace.com. We're also on LinkedIn and social media where we promote things like that, the happy hours that we do here in Colorado. So happy to have people look us up, and love to engage in a variety of ways with folks who are interested.
Again, well, thank you much and appreciate the time. Let's stay in touch.
Yeah, thank you, Dave. Take care.